Assalamu alaikum wa rahmatullahi wa barakatuh, everyone. Today our topic is crude oil and crude oil chemistry. Petroleum or crude oil. Always we said petroleum. Petroleum, it is from two part of this term. Petroleum from Greek mean rock. Petro means rock. And oleum, it is oil. يعني the oil of rock. Oil is naturally occurring flammable liquid consisting of complex mixture of hydrocarbon of various molecular weight and other liquid organic compounds that are found in geologic formation beneath the Earth's surface. Crude oil is composition of hydrocarbon chemicals composed solely of hydrogen and carbon in various molecular arrangement and other compound which is usually brown or black in color. The name petroleum cover both naturally occurring unprocessed crude oil and petroleum products that are made up of refined crude oil. يعني all the products which come from crude oil also called petroleum. Petroleum is recovered mostly through the oil drilling. This comes after the studies of structural geology. This is the structure or the content of crude oil. There is fuel gas, there is naphtha, there is diesel, petrol, kerosene, fuel oil, and bitumen. Composition of crude oil. Overall properties of crude oil are dependent upon their chemical composition and structure. Not all compounds contained in crude oil are hydrocarbon. There are present also impurities, small quantities of sulfur compound, nitrogen compound, oxygen compound, and metals. The composition of crude oil on the elemental base fall within certain range regardless of its origin. The sulfur from these heavier sulfur products can only be removed by converting the sulfur to H2S or in hydrotreating process operating under severe condition or temperature and pressure, and over suitable catalyst. The lighter sulfur compound are usually removed as mercaptan by extraction with caustic soda or other suitable properties solvent like Mirox. The structure or the composition content of crude oil based on elemental, as carbon is about 83 to 87%, weight percent, hydrogen 10 to 14 weight percent, sulfur 0.05 to 6%, nitrogen 0.1 to 0.2 weight percent, oxygen 0.05 to 2 weight percent, nickel, which is this metals, is 120 ppm, and vanadium is 1200 ppm. Now here there is some definition before I start the topic. Atom, what we mean by atom? Atom is the smallest unit of matter that retain all of the chemical properties of an element. And atom consists of nucleus, which is contain proton and neutron, and there is shell also, which contain the electron. Compound, what we mean by compound? Compound are substances made from atoms of different elements joined by chemical bond. They can only be separated by chemical reaction, like water, H2O. This is compound. But hydrogen is atom. Hydrogen is atom, but H2O is compound. So what is mixture? Mixture is made by simply mixing together element and compounds. No new chemical bond are formed. Now, if we mix 2 or 3 elements together, but there is no chemical reaction, we call that mixture. Hydrocarbon compound is the compound which consists of hydrogen and carbon only. Now what we mean by electron configuration? Electron configuration is the distribution of electron of an atom in the shell. So in the first shell, second shell, third shell, and like this. And the level of energy. So this is the periodic table. Here in periodic table, we have just to see where is the hydrogen atom and where is the carbon atom. Hydrogen atom is the first atom in periodic table. This is hydrogen atom. Carbon atom is number 6 in the periodic table. This is number 1, 2, 3, 4, 5, 6. This is carbon. So this means that hydrogen is number 1 and carbon is number 6. Hydrogen 1 electron only and carbon is 6 electron. Now we come to the electron configuration of hydrogen. Hydrogen, for each element there is atom. In each element there is atom. This atom consists of the nucleus and the shell. Maybe 1 shell, 2 shell, 3 shell, according to the number of electron. Because each nucleus contains number of proton and number of neutron. In the shell there is electron. The number of electron is always equal to the number of proton in the atom. So in the atom, proton, as I said, proton and neutron. In the shell there is orbital. Orbital is the space in which the electron is moved in. There is in the first shell there is 2 orbital. يعني either 1 orbital or 2 orbital. In the second shell there is 4 orbital. So each orbital have to be filled by 1 or 2 electron. If it is 1 electron, it is unsaturated and become unstable. If it is 2 electron, so the atom is become stable. So in hydrogen, we have only 1 electron in the first shell. 1 electron in the first shell. So that means that the hydrogen atom is unstable. So that is why we not find hydrogen atom in nature. We find only hydrogen as molecule, H2, because each hydrogen atom combined with other hydrogen atom and to share its electron to fill one orbital sharing between these 2 atoms. So, and make that as bond. See, this is the hydrogen atom. This is the hydrogen atom. This is the hydrogen atom, and then connect together to make hydrogen molecule, H2. This is which we find in nature, hydrogen molecule. Now we come to the carbon. Carbon atom consists of also nucleus, which contain proton and neutron. And there is 2 shell because we have 6 electron. Here there is 6 electron. 4 electron is in the first shell because first shell there is 2 orbital. Each orbital filled with 2 electron. Each orbital filled with 2 electrons. So this is 2 electron and this 2 electron become 4. So remaining 2 electron. 2 electron. Here in outer shell there is 4 electron, 4 orbitals. So each orbital have to occupied by 2 electron. But unfortunately there is only 4 electron, and there is no 8 electrons. So this is each orbital consists of 1 electron only. So it also become unstable. It need to connect with other element which sharing its electron in each orbital. So become the first shell only 2 electron because 1 orbital only. 1 orbital in the center is filled with 2 electrons. The outer shell is 4 electron. In each orbital there is 1 electron. So all orbital in the outer shell is unsaturated. So need to connect with other element. So if connect with other carbon, so this atom connect with 4 atom of carbon. 4 atom with carbon, and each atom also connect with other atom. So with each atom connect with another, the structure, all the structure become carbon-carbon bond. Carbon-carbon bond. This bond, as we know, it is called covalent bond. So this is the structure of carbon-carbon atom. This is also other structure for carbon-carbon atom. And we have 3 types of structure for carbon-carbon atom structure only, like coke and graphite and diamond. Here there is carbon-carbon atom and there is carbon-hydrogen bond. there's hydrogen carbon bond and carbon hydrogen bond, so consist or compose this complicated structure, which is this is natural pitch. There is simple structure, not like this, This is hydrocarbon compound, carbon and hydrogen. See, each carbon connect with hydrogen with, there is from here, there is electron from here, and there is electron from carbon, here from hydrogen from carbon, also here from hydrogen from carbon. Each two electron filled one orbital and make covalent bond. So carbon make 4 covalent bond with hydrogen, or make another bond with other carbon atom, so remaining only 3 electrons in the outer shell with connected with by hydrogen, and the other atom also by hydrogen. If long molecule chain like this for carbon, so each carbon in the each terminal connect with the 3 hydrogen, and in the middle connect with 2 hydrogen. See, in the terminal there is 3 hydrogen, in the terminal, this terminal also 3 hydrogen, and here 2 hydrogen in each in the middle. So this is, we call it hydrocarbon compound. In a crude oil, we have 2 types of compound. We have hydrocarbon compound and non-hydrocarbon compound. Hydrocarbon compound is aliphatic, aromatic, naphthenic, and this is the percentage of each one. Aliphatic is 25%, aromatic is about 17%, and naphthenic is about 50%. And this is the structure, linear structure. This is for hydrocarbon compound, like this 1, 2, 3, 4, 5 atom, carbon atom, and hydrogen always there. This line structure, it does not appear about how much the carbon and hydrogen on the line. So this means 5 carbon atom and 12 hydrogen atom. So this is pentane, and this is what? This is 2,2,4 trimethyl pentane. And this is also aromatic double ring, and this is naphthenic cyclic compound with free radical or with alkyl group. And this is multiple ring of aromatic compound. This is for hydrocarbon. So for non-hydrocarbon, we have also different type of compound. We have sulfur compound, about from 0 to 8%, and nitrogen compound from 0 to 1%. We have oxygen compound from 0 to 3%, and there is metal up till from 0 to 100 parts per million. So this is the consistent or the content of crude oil. The composition of crude oil, the hydrocarbon in crude oil are mostly alkane, paraffin, cycloalkane, naphthene, and various aromatic hydrocarbon, while the other organic compound contain nitrogen, oxygen, and sulfur, and the trace amount of metal, as I said, about 100, less than 100 ppm, such as iron, nickel, copper, and vanadium. The exact molecular composition varies widely from formation to formation, but the properties of chemical elements vary over very narrow limit as follows. Composition by weight. Element in percentage. Carbon is about 83 to 87 weight percent. Hydrogen is 10 to 14 weight percent. Nitrogen is 0.1 to 2%. Oxygen 0.05 to 1 to 5%. Sulfur from 0.05 to 6%. Metals less than 1.1%. For different type of hydrocarbon molecule appear in crude oil, the relative percentage of each varies from the oil to oil, determining the properties of each oil. Composition by weight. So we have in each, in different type of crude oil, there is paraffin, naphthene, aromatic, and asphaltic. So paraffin percentage about 30%. The range is 15 to 60%. Naphthene is the average is 49%. This is from 30 to 60. Aromatic 15% from 3 to 30, and asphaltic is 6%, and the remainder. Alkane are saturated hydrocarbon having the general formula CnH2n plus 2. The simplest alkane is methane, CH4, one carbon atom, and there is 4 hydrogen atom. So N is 1 and H is 4. The principal constituent of natural gas, methane, ethane, propane, and butane are gases hydrocarbon at ambient temperature. And the other like this, we see this table. Now we have methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane. This is the first 10 compound of alkane or paraffin. And there is also isomer for each started from butane. There is 2 isomer. What we mean by isomer? The branch chain of the same structure of the compound. So butane there is 2 isomer, pentane is 3, and so on. So now if we come here, there is from 1 start from 1 carbon, 2 carbon atom, 3 carbon atom, 4 carbon atom, 5 carbon, 6, 7, 8, 9, 10, 12, 30, 20, 20, 30, 100, 1000, maybe more than 1000 carbon atom, and there is also hydrogen. So the number of hydrogen is equal the number of carbon atom by 2 plus 2. So this is called C1, this is called C2, this is called C3, يعني for abbreviation, for simplified explanation. So we call methane C1, we call ethane C2. So C1 is gas. In alkane or in paraffin, C1 is gas. And also C2 is gas. And we call these 2 gas natural gas. C3, which is propane, and C4 also gas, but under vapor pressure it become liquid. This is consists the LPG, liquefied petroleum gas, which we use it in kitchen for cooking. So from C5 till C17 is liquid. From C5 till C17 is liquid. So C5, C6 we call it light naphtha. C7, C8 we call it heavy naphtha. And this is light naphtha, and heavy naphtha we send it for benzene pool to produce benzene after another treating or another processing, because light naphtha and heavy naphtha is not suitable to become directly as petrol. So from C9 up to C17, this is also liquid, but this liquid consists of contain kerosene, diesel, and fuel oil. So the compound which contain more than 18 carbon atom become either semi-solid or solid, which we call it wax or lubrication oil or bitumen or petroleum coke. So this is the properties of alkane. So the structure, the structure formula of alkane. See, this is the first one, the simplest one, methane. This is ethane. And also the nomination of this, we call it, each one ended by the letter A-N-E. The last 3 letter is A-N-E, an or N. So methane, ethane, propane, butane, pentane. Then this is pentane, normal pentane. So this is isopentane. This is neopentane. And this is octane, and this is also isooctane. So what I mean by answer? So this is normal pentane, and this is isopentane, because this is straight chain. There is no branch, so it is normal. This is, we call it iso because there is a branch, and there is a system for nomination not mentioned, but in future I give one topic about one lecture about the nomination of hydrocarbon. But we can now only call it ISO because this ISO يعني different than this ISO. So this is ISO bentane and this is ISO bentane, so it is different, so need special nomination way. So we come to properties of paraffin. Paraffin, as we said, it is alkane. Alkane are colorless and odorless. They possess weak van der Waals forces of attraction. Alkane have 1 to 4 carbon atom. It is gases, as I mentioned before. From 5 to 17 carbon atom, they are liquid. And alkane have 18 or more carbon atom become solid or semi-solid at 298 Kelvin temperature. Low octane number. All alkane is low octane number except the ISO. ISO is more octane number than the normal straight chain. Also have high viscosity index and not very reactive and non-polar solvent. Non-polar solvent, that means it not solve in water, not solve in water because water is polar. It is solved only in non-polar solvent. Alkane are only weakly reactive with ionic and other polar substance. The acid dissociation constant value of alkane are above 60. Hence, they are practically inert to acid and base. It is not react with acid and base. This inertness is the source of term paraffin, with the meaning here of lacking affinity. يعني it is unreactive. In crude oil, the alkane molecule have remained chemically unchanged for millions of years. يعني the compound, the molecular of paraffin, it is not changed in crude oil. If we stored it for millions of years, it is remain as it is. However, redox reaction of alkane is particular with oxygen and halogen. يعني substitution reaction, removing one hydrogen and substitute by halogen or oxygen. For it is possible to react with these as the carbon atom are in strongly reduced condition. In the case of methane, the lowest possible oxidation state of carbon is -4 is reached. Reaction with oxygen, if present in sufficient quantity to satisfy the reaction stoichiometry, lead to combustion without any smoke, producing carbon dioxide and water. A free radical halogenation reaction occur with halogen, leading to production of haloalkane. In addition, alkane have been shown to interact with and bind to certain transition metal complex in carbon-hydrogen bond activation. A free radical molecule with unpaired electron play a large role in most reaction of alkane. That is what I mentioned about ISO. There is a branch. There is a free radical connect with hydrocarbon chain. So such that rock formation where long chain alkane are converted into shorter chain alkane and straight chain alkane into a branched alkane in isomerism or isomer. In highly branched alkane, the bond angle may differ significantly from the optimal value 106.5 degree in order to allow the different groups sufficient space. This causes a tension in the molecular known as steric hindrance and can substantially increase the reactivity. The application of paraffin depends on the number of carbon atoms. The first four alkane are used mainly for heating and cooking. يعني the gas 1C1, C2, C3, C4 used for heating, cooking purpose, and in some countries for electricity generation. يعني in gas turbine to generate power. Methane and ether are the main composition of natural gas. They are normally stored as gases under pressure. It is, however, easier to transport them as liquid. This requires both compression and cooling of the gas to convert these two gases, يعني methane and ethane, to liquid need pressure and needs cooling. Propane and butane are gases at atmospheric pressure that can be liquefied at fairly low pressure, and they're commonly known as liquefied petroleum gas, or we call it LPG. Propane is used in a propane gas burner and as a fuel for road vehicle, used solvent in propane deasphalting unit, used also for as a fuel in refineries. This is the propane. Butane also in the space heater as solvent and disposable cigarette lighter. Both are used in propellant in aerosol spray. يعني we means they use it with insecticide, with perfume as spraying agent. From pentane to octane, يعني from C5 to C8. From C5 to C8, from pentane to octane, the alkane are highly volatile liquid, متطاير. They are used as fuel in internal combustion engine, مكان الاحتراق الداخلي, as they vaporize easily on entry into the combustion chamber without forming droplets, which would impair the uniformity of the combustion branch chain. Alkane are preferred as they are much less prone to premature ignition, which cause knocking, than their straight chain homologies. So that يعني straight chain is not good for ignition because it is highly ignited, so it makes a knocking during combustion in the car engine than the يعني more than the straight isochain. Isochain is better for ignition in combustion engine. The propensity in the premature ignition is measured by the octane rating of fuel, where it is 2,2,4-trimethylpentane. 2,2-trimethylpentane is, or isooctane, is the arbitrary value of 100 octane number, and heptane, the straight chain, which is contains 7 carbon atom straight chain, which is called heptane, have the value of 0 octane number. Apart from their uses as a fuel, the middle alkane are also good solvent for nonpolar substance. Alkane from نونان, يعني from 9 carbon atom to, for instance, hexadecane. Hexadecane means 16 carbon atom. Are liquid of higher viscosity, less and less suitable for use in gasoline. They form instead the major part of diesel and aviation fuel. Diesel fuel are characterized by their cetane number, cetane being an old name for hexadecane. However, the higher power point of this alkane can cause problem at low temperature and in polar region, where the fuel become too thick to flow correctly. Alkane from hexadecane upward from the most important component of fuel, oil and lubricating oil. In the later function, they work at the same time as anti-corrosive agent, as their hydrophobic nature means that water cannot reach the metal surface. Hydrophobic means dislike water. Hydrophobic dislike water. So the water cannot reach the metal surface. Many solid alkane find use as paraffin works, for example, in candle. This should not be confused, however, with true works, which consist of primarily of ester. Paraffin with chain length of approximately from 35 carbon atom and more, so are found in bitumen, used for example in road surface, in roofing, or in any other uses. However, the higher alkane have little value and are usually split into lower alkane by cracking. يعني either used as bitumen or cracked by cracking process to convert it to light component. Light component we means like kerosene or gasoline or diesel. Some synthetic polymers such as polyethylene and polypropylene are alkanes with chain containing hundreds of thousands of carbon atoms. The material are used in numerable applications, and billions of kilograms of these materials are made and used each year. If naphtha fraction contains the compound, the first two or can be converted to benzene. If naphtha fraction contains these compound, the first two can be which compound? This compound. This is compound. Containing compound, the first two can be converted to benzene, and the last compound can hydrated to toluene, and this is not needed now. And now we come to this equation, which as yet that all hydrocarbon or all alkane got combustion reaction. Combustion reactions mean the reaction of hydrocarbon combined with oxygen. So each molecule of hydrocarbon, the easiest molecule of carbon CH4 methane, when it reacts with oxygen, it needs two oxygen molecule to produce CO2, carbon dioxide, and water, and also give heat. So if we get the 3 carbon atom, يعني propane, 3 carbon atom with 8 hydrogen atom, it need 5 molecule of oxygen to produce 3 molecule of carbon dioxide and 4 molecule of water, and also heat. It gives heat. So for 2 carbon atom and 4 hydrogen atom, يعني ethane, when it reacts with oxygen, it needs 3 molecule of oxygen to give 2 molecule of carbon dioxide and 2 molecule of water. Now this is about alkane or paraffin. Now we come to another compound or type of crude oil, which is called naphthalene. So naphthalene are saturated hydrocarbon grouping with general formula CnH2n, arranged in form of a closed ring, cyclic. It is cyclic and found in all fraction of crude oil except the very lightest, يعني only in the first, second, 3 fraction is not found, but from the third fraction it is found with crude oil. If a crude oil single ring naphthalene, monocycloparaffin, with 5 and 6 carbon atom predominate, with 2 ring naphthalene dicycloparaffin found in the heavier ends of naphtha. Cycloparaffin, which is called naphthalene, saturated cyclic hydrocarbon, normally known as naphthenes, are also part of the hydrocarbons constituent of crude oil. The ratio, however, depends on the crude oil type. The lower number of naphthalene are cyclopentane, cyclohexane, and their mono-substituted compound. They are normally present in the light and the heavy naphtha fraction. Cyclohexane substituted cyclopentane and substituted cyclohexane are important precursors of aromatic hydrocarbon. Dimethyl cyclohexane are also important precursor for xylene. Heavier petroleum fractions such as kerosene and gas oil may contain 2 or more cyclohexane rings fused through 2 phenyl carbon. The example shown here, we have 3 molecules of cyclic. This one is methyl cyclopentane, and this is cyclohexane, and this is methyl cyclohexane. So this example, there are 3 naphthalene of special importance. Why it is special important? Because if naphtha fraction contain these compounds, the first 2 can be converted to benzene. This can be converted to benzene. And how converted to benzene? By dehydrogenation. يعني it becomes, there is double bond here when it is removed hydrogen or lose hydrogen, because here we have C6H12. When it is removed 6 atom of hydrogen, it becomes C6H6. And also here we have about, we have C7H1214. So when it loses 6 hydrogen atom, it becomes double bond here, so it becomes C6H6, and this is CH3, so it becomes ethyl benzene. This is become benzene, and this is become ethyl benzene. And this is also converted or isomerate to benzene, or during dehydrogenation reaction. So this is, if it become methyl benzene, it is called toluene during processing. So this is very important to treat compound in naphtha. This is another example of cyclo compound or cycloparaffin or naphthene. All names is correct, either cycloparaffin or naphthene. So this is cyclopropane, cyclobutane, cyclopentane, cyclohexane, and this is also cyclohexane. This is cyclohexane. This is methyl cyclohexane, and all these. This is free radical, طبعا alkyl group, alkyl with cyclopentane, so alkyl pentane. This alkyl either methyl or methyl, ethyl, propyl, butyl, any alkyl group connect with the chain. This is also bio ring, and this is methyl group with pentane. This is dimethyl group with pentane, cyclopentane, and this is methyl ethyl group with pentane. So the general properties of naphthene. Naphthene is cyclic alkane. The structural formula is CnH2n. Two hydrocarbons or other groups may be bonded to carbon in an alkane ring. Cyclic alkane CnH2n plus 2, it become, if it is alkyl group, so 2n minus 2 for every double bond present. Every double bond there is 2 hydrogen removed, so it becomes 2n minus 2. The physical properties of naphthene, it is non-polar. It is non-polar. Good industrial solvent for other non-polar compound, insoluble in water, liquid at room temperature. Alkane unreactive because it is saturated. Alkene طبعا in naphthene لا, there is alkane and alkene. Alkene when there is double bond, so we call it alkene. So alkene is reactive, but alkane is not reactive. All compound are combustion reaction like other compound. Olefin, I not explain olefin here. I not go deep because olefin is not found or not existing in crude oil, but it is produced during our processing in refinery, like a cracking reaction or any other process. It become or produce olefin compound. Olefin compound is the chain which contain carbon-carbon double bond, and starting from ethene, the name also ended by ene instead of ane, ene. So instead of ethane, we call it ethene, propene, butene, and like this. So this is double bond, and this is very reactive compound. And this is the structure of each. This is ethene, propene, butene, and this is also isobutene, trans-pentene, 2-pentene, and isobentene. So we not go deeply in the eye because not needed, but only the properties of olefin. It is CnH2 and the structure. and the physical properties boiling point depend on chain length, but slightly less than alkane. The boiling point of olefin is less than paraffin. Also non-polar, all hydrocarbon non-polar, يعني it's not soluble in water and less dense than water. يعني less dense than water. يعني when we mix together it has become immiscible liquid and the water is down and olefin is up. Chemical reactivity, alkene are quite reactive because of the presence of the double bond, so it is unstable. Many small components react by addition. يعني during the reaction the double bond is breakdown and addition molecule is join the chain. All compounds are combustion reaction. Now we come to the last one, or the last group of hydrocarbon, which is aromatic compound. It is lower number of aromatic compound are present in small amount in crude oil and light petroleum fraction. The simplest molecular aromatic compound is benzene, which contains 6 carbon atom and 6 hydrogen atoms, C6H6, and toluene, which contains 7 carbon atom and 8 hydrogen atom, and xylene also, which contains 8 carbon atom and 10 hydrogen atom, mononuclear. Aromatic compound found in variable amount in crude oil. Benzene, toluene, and xylene are, what we call it PTX, are important petrochemical intermediate as well as valuable gasoline component. تستخدم كcomponent in gasoline and also in petrochemical intermediate. Separating PTX aromatic from crude oil distillate is not feasible because they are present in low concentration, enriching naphtha fraction with these aromatic is possible through catalytic reforming process. Binuclear aromatic hydrocarbons are found in heavier fraction than naphtha. Trinuclear and polynuclear aromatic hydrocarbon in combination with heterocyclic compound are major constituents of heavy crude and crude residents. Asphaltene are complex mixture of aromatic and heterocyclic compound. The following are representative examples for some aromatic compounds. See like this is benzene, this is toluene, and this is xylene. Xylene, it comes with three, I will explain later about the formation of the structure of xylene. Here, endene, one ring 6, one, and the other is 5 carbon ring together. And this is naphthalene, which is volatile also, and we use it at home always. Most of you see this naphthalene. This is biphenylene, and this is anthracene, and this is phenylene. All this. This is 3 benzene ring. This is also 3 benzene ring, but different in structure. So this is called anthracene, and this is called phenylene. The properties of aromatic. Aromatic compound generally nonpolar and immiscible with water. Like other hydrocarbon, it is nonpolar. As they are often unreactive, they are useful as solvent for other nonpolar compounds. Due to their high ratio of carbon to hydrogen aromatic, it is characterized by sooty yellow flame. When it is during combustion, it gives sooty yellow flame. And also the viscosity index is very low for aromatic. Aromatic have usually having high boiling point. Why? Because starting from C6, from benzene. Low pour point, freezing point, high octane number. So it is desirable with gasoline. High viscosity and low viscosity index. And big characteristically with a flame with much soot. Red flame with such much soot. As this behavior like saturate, they resist oxidation. In petroleum fraction, aromatic beyond the 3-ring structure in anthracene are probably non-exist in crude oil. يعني only till 3-ring it is exist in crude oil. More than 3-ring it is not exist in fuel crude oil. Aromatic usually extend their presence from temperature of 80 degree centigrade onward and will dominate in lower middle cut and heavy cut, يعني with kerosene and diesel. Aromatic compound property, actually the light aromatic bitters do not exceed even 5%. يعني this is only 5%. This is the light aromatic. Bulk of aromatic are with side chain and naphthenes and exist in heavier portion of crude. All these in the heavier portion of crude. يعني from diesel up or from kerosene up, but not found in naphtha or with gases. This is example of 1 ring or 2 ring, 3 ring, like this. And if you have properties of electronic resonance, hydrocarbon are quite stable. Benzene is quite stable. Why? Because of its resonance. Yeah. What we mean by resonance? Resonance is the transition of double bond from location to other location. High octane value render aromatic excellent gasoline blend composition. All aromatic is high octane number, so it is good to use with gasoline as fuel. High solvency power, it makes it good commercial solvent because solvency power is high, so it is good as solvent. They are poor viscosity index component in lubricating oil. So in lubricating oil, we need high viscosity index. What we mean by viscosity index? Viscosity index is the variation of viscosity and during the variation of temperature. So if the temperature is high, there is no viscosity, that means. So it is not desirable with lubrication oil. Aromatic and kerosene produce smoky flame, low smoke point. So also not desirable with kerosene because it gives smoke. So now we come to about xylene. Xylene is dimethyl benzene. And this is dimethyl benzene, this is dimethyl benzene, this is dimethyl benzene. So, but the commercial name of these all it is xylene. But different from one to other, different in structure and also different in properties. So this is called, if it is one beside adjacent to other, the radical or the methyl group is adjacent to each other. So this is called orthoxylene because adjacent. If there is one carbon separated these two group, one carbon, this is no connection, only this and this, so it is called metaxylene. And if it is opposite, like this structure, so it is called paraxylene. So this is orthoxylene, and this is metaxylene, and this is paraxylene, and each one is different in physical and chemical properties. Aromatic compound can contain more than one 6-member ring. Naphthalene, anthracene, and phenanthrene are examples of aromatic compound that contain 2 or more fused benzene ring. General properties of hydrocarbon: C6H6, only one hydrogen or other group may be bonded to the carbon in benzene ring, so like xylene. Nonpolar, good industrial solvent for other nonpolar, insoluble in water, liquid at room temperature. Relatively unreactive, even through double bonds are present. Here it is unreactive, not like olefin. Aromatic do not undergo addition type reaction. Reaction occur by substitution of the hydrogen for another group. All compound as combustion reaction. Type of composition of crude oil. Now we finish all the group of crude oil, يعني paraffin, naphthalene, olefin, and aromatic. Now the composition of crude oil like this: bona. Bona means paraffin, olefin, naphthalene, and aromatic. BNA means paraffin, naphthalene, and aromatic. Bione means paraffin, isoparaffin, olefin, naphthalene, and aromatic. Sara saturate, aromatic, resin, and asphaltene. This is according to composition, the name of crude oil according, or analysis of according to constituent. Elemental analysis like carbon, hydrogen, sulfur, nitrogen, oxygen. And fractionation of crude oil, this is the first two compound in crude oil in paraffin, يعني C1, C2 it become natural gas, C3, C4 is LPG, and from C5 to C12 it become gasoline and يعني also petroleum ether, and it become kerosene, then C12 up, and from C15 up it become diesel, and then from 16 up it become liquid lubrication oil, and then petroleum fuel or petroleum coke. Also, this is the barrel of crude oil, and this is the content of this barrel. So thank you for today's topic. Thank you for listening. Thank you for sharing. Thank you for everything, and we'll see you in other topic next time.